Everybody. So today we're going to be discussing molarity. So first off, what is molarity? Well, it's one of the many ways we can measure the concentration of a solution. When we describe a solution as concentrated, what we mean is that a lot of solute is dissolved in the solvent. So something that has a high concentration has a large proportion of solute. Something that's less concentrated or diluted is something that has less solute in the solution. And so molarity is a way that we can put a number on that measurement. We can measure the molarity of a solution and determine how much solute is in that solution. So the calculation for molarity is the moles of solute, so again, that amount of solute, divided by the liters of solution. Now it's important that we understand that it's the total volume of the solution that is going into this calculation, not just the amount of solvent that we add. Because if we add a large amount of solute, that could actually increase the volume of the solution. And so the calculation is the moles of solute divided by the total volume in liters of the solution. And again, it's going to be a greater value for more concentrated solutions. So if something has a large amount of solute, it's going to have a greater molarity. We can use this handy triangle here to do our calculations. So you're going to see this triangle and I'll explain how to use it. But notice that we have moles on top, and then the capital M represents molarity, and then the capital L on the bottom represents liters. And again, that's the volume of the solution measured in liters. So again, we're going to take moles of solute and divide it by liters of solution in order to calculate molarity. The amount of your solute has to be in units of moles. So if you're given an amount of solute in any other unit, it's going to have to be converted to moles using dimensional analysis. More often than not, the amount of solute is measured in grams. So a lot of times you're going to be doing a gram to mole conversion. The amount of solution has to be in liters. If it's measured in any other unit than liters, it's going to have to be converted to liters using dimensional analysis. So a lot of times the volume of the solution is going to be measured in milliliters. More often than not, that's what we use in the lab. And so we would have to convert milliliters to liters using dimensional analysis. So just understand that before you ever get to the molarity calculation, you're probably going to have to do some dimensional analysis beforehand. Because before you can do the molarity calculation, you have to have units of moles and liters. So here's our first example problem. We have 0.750 grams of sodium chloride dissolved in 250 milliliters of solution. And the question is, what is the molarity of that solution? So the first step in any molarity problem is to look at the values that you're given and identify what they represent in the molarity formula. So we're given an amount of solute in grams. The amount of solute is going to have to be converted to moles because moles is going to be used to do that molarity calculation. So although we do have an amount of solute, it's in grams, we're going to have to convert it to moles. And then we have 250 milliliters, which is a volume. And that volume is going to have to be converted to liters. Again, we have to make sure that we have moles and liters in that molarity calculation. So that volume in milliliters is going to have to be converted to liters. So the next step is to go ahead and do those conversions. So if we start with that 0.750 grams of sodium chloride and then use dimensional analysis, keeping in mind that grams on top and grams on the bottom have to cancel out, we can go ahead and convert grams to moles. And so this turns out to be 0.0128 moles of sodium chloride solute. The 250 milliliters has to be converted to liters, and the conversion factor there is 1,000 milliliters is equal to 1 liter. So again, I set up that conversion factor so that my units cancel out, and once I multiply, I end up with 0.250 liters of solution. So then we use the molarity formula to calculate the desired variable. And here's that triangle that I was talking about. So what we do is to use the triangle, you actually cover up the variable that you're trying to calculate. So in this case, we wanted molarity, so I went ahead and covered that up in the triangle. So cover up the thing you're calculating. What's left are the two variables that I actually have numbers for. And so what the triangle is telling me to do here is take moles and divide it by liters in order to solve this problem. So if I have one variable on top of the other, then I take the top variable and divide it by the bottom variable. And that will give me the one that's covered up. So I'm going to take moles and divide it by liters, and that's going to give me molarity. So once I do that, I take the 0.0128 moles of solute and divide it by that 0.250 liters of solution, and I end up with a molarity of 0.0512. So we would describe that as a 0.0512 molar solution of sodium chloride. So once you're describing a solution, yes, that's the calculated molarity, but we would describe that as a 0.0512 molar solution of sodium chloride. So here's another example, just another way to show how to solve these problems. How many moles of sodium chloride are dissolved in 500 milliliters of a 0.350 molar sodium chloride solution? Okay, so again, that first step is to look at the problem and think about what we actually have here. So we have that 500 milliliters, which is a volume, correct? And so that's going to be the volume of solution, but our volume has to be in liters in order to do the molarity calculation. So we have to convert that to liters. Now, the molarity was given to us in this case. It does not have to be converted to anything else. So we can just use that molarity as is. So the next step is to go ahead and do that conversion. We have to take the 500 milliliters and again use that 1,000 milliliter to 1 liter conversion factor to convert that to liters. And then we can use the molarity formula. So in this case, we were asked to calculate moles. So we're going to go ahead and cover up moles, and what's left are molarity and liters at the bottom. And if those two variables are next to each other, then what I actually need to do to solve for moles is multiply. So again, to use the triangle, what I did was I covered up my desired variable, and then what was left was two things next to each other. And so I need to multiply the two values that I have in order to solve this problem. So it's going to be molarity times volume in liters. And so once I take that molarity of 0.350 and multiply it by the 0.500 liters that I have, I end up with 0.175 moles of sodium chloride. So that would be the answer to this problem. Now, what if the question didn't ask me for moles? What if the question asked me for mass of solute? Mass is, of course, not in that molarity calculation, right? Moles and liters are, but mass is not. So how would we solve this problem a little bit differently? Well, we really wouldn't. We would go through exactly the same steps, and we would end up with moles. Because what we had was a volume and a molarity, and all we can do with that is find moles, because that's the third variable in that equation. So from the previous problem, we would solve it exactly the same way. But if they asked us for mass, then we would go ahead and convert that to grams after we solve for moles. So once we have moles, we can easily convert that to grams using dimensional analysis. So again, I would take my answer in moles and multiply it by the molar mass of that compound from the periodic table, keeping in mind that my units have to cancel out. So if I'm starting with moles, I need moles on the bottom of that conversion factor, which means I'm multiplying times grams on top. And we end up with 10.2 grams of sodium chloride. So if you're using the molarity formula, you can only use units of moles, molarity, and liters. If any other units are mentioned, you're going to have to do those conversions either before or after you do the molarity calculation. So just keep that in mind. If you're using the molarity calculation, it has to be in units of either moles, molarity, or liters. Any other conversions have to happen either beforehand to get to those units or afterwards to get to a desired unit that's not in the molarity calculation. All right, guys, thanks for listening today.